going to move on to not another case, because we're still talking about straight line equations, but with a different given. Now, if you are given instead that a straight line passes through 2 points instead of 1, so you have points C and D, and they're both, of course, position they're position vectors, and points C and D, and you're given that, and that is basically it. How do you know? Well, it builds on the first one. Now let us first draw it. So if we have here, oops, that was okay. So if we have the graph, our ij graph, and we know you have the vector C, or position vector C, and you have the position vector D, and you know it passes through both. So you know it passes through C and D, which means it is probably a vector that's this way. It can be in either directions, but let's just assume it goes this way. Now, what does this tell us? It tells us that you're going to go from here to there. The direction of your vector is from here to there, and in order to do that, you're going to do you want to go from here, so it's CO plus OD. So it's CO plus OD. In other words, it is the minus C plus D. That is the direction. This is your direction, which means that if you want to write your straight line equation that we have learned for this chapter, R equals to BT plus A, where B is something parallel to it because it's an indicator of direction. Here our B is going to be instead equals to D minus C, because that's our direction. This is what it's parallel to, into T plus A is any position vector passes through, so let us just go with C or D, it doesn't matter. So it can work as C or D minus C plus into T plus D. Both of these are equations for that will give you the straight line equation. So vector D minus C here is known as the direction vector, and the direction vector is a vector that is parallel to the straight line, which gives you again the actual solution. And by this you know how to counter any example you get on expressing a vector in a straight line format. You just think of what is the direction and what is any position vector it passes through, and you're going to get through. Now, building on the straight lines, now we're going to move to our 8th case. I'm starting to lose count of the cases. Anyway, our 8th case, which is how to determine if two straight lines intersect or not. So, do they intersect? Now, in order to find this, you're going to be doing the exact same thing you've done with normal straight lines. So when you need to deal with more than one straight line in the same question, you're going to first of all make sure you're going to use different parameters, and then you're going to equate them like you do with any other like you do with a normal straight line equation. Now, in order to explain this further, to make it more obvious for you, I'm going to go for an example instead. So, if I tell you that the question says that show that the lines with vector quantities R equals to 3i, here we go, 3i plus 8j minus 2k, that will be the position vector it passes through, plus t into 2i plus j plus 3k, and that will be its direction. And then we have another one that is also r, and it's 7i plus 4j plus 3k, and we're going to use here another parameter s. It's still a parameter, but we're using different one because they simply have different values, and it also has the same, almost the same direction, just except differently on the third dimension. Now you want to see that they both intersect, and you want to find that point of intersection. So what you're going to do is that you want to equate them just like you'd equate any two straight lines in order to prove they are they intersect. So we're going to have here 3 plus 2t. Here we're going to have 8 plus 1. Here we're going, this is going to be 8 plus t. Here is going to be 3t minus 2. And that will be your first one. And you want to equate it to 7 plus 2s, 4 plus s, and 3 plus 4s. So you want to equate them to each other in order to prove that they are actually going to intersect. So what you want to do is that you're going to need to compare each one with the one opposite to it. And you need to prove that they have the same. Okay, so you're going to equate all these, and you're going to say you need to find t and s. So you're going to say 3 plus 2t equals to 7 plus 2s. And you need to say that 8 minus t equals to 4 plus s. And 3 plus 2t, is it 3 plus 2t? Yeah. Oh, I wrote it here wrong. So 3 plus 2t is going to equal to 7 plus 2s. 3 plus 4s. I'm confusing you. So yes. So if you do these, and then you're going to say it's 7 plus, is it 4k? Yeah, 4s, 4k, 3t minus 2. Here we go. Oops, there. So you're going to actually equate them to each other. You want to find t in terms of, you want to find t and s. You're going to solve for them. You're going to equate each and every one to the one opposite to it. And then this will eventually give you the values for t and s. And for this question, your t is going to be equal to 3 and your s is going to equal to 1. You can solve it on and just check it, but to save your time of calculations, it's just simple algebra. So yes, if the two lines exist, then you need to prove that they're going to equal the same way. In other words, you're going to say that minus 2 plus 3t, which is your last here. So here it's minus 2 plus 3t. It has to equal to 3 plus 4s 2. If when you solve for these, you're going to get t and s. You're going to replace them here, and you need to show that they're actually true. Let me just solve it out. Although I'd rather not, but just so you know, here what we have is, if we add or subtract, here we go. So if we want to express it in t, it's equal to 7 plus 2s or minus 3 over 2, which is 4 plus 2s over 2, which equals to 2 plus s. So that's our t. So here our t is 2 plus s, so 8 minus 2 minus s is equal to 4 plus s. And here it's going to be 6 minus 4, 2, and this is going to be 2s, so s is equal to 1. And if you want to replace it in our t, you're going to say t equals to 2 minus 1, which equals to, it's 2 plus 1 here, so 2 plus 1, which equals to 3. And then we have t, s, and 3. Now if we replace it here, we're going to say that minus t plus 3 into 3 is minus t 2 plus 9, which is 7. And this is going to be 3 plus 4, which is also 7. And if it's true, then that means it's true. And that is what I meant by you solve for the first two, and then you check in the third one. And that would be it.